All right, so just to kind of set things up for you here, guys, so you know where we're headed. Obviously, you're going to go to Science 10 AP because that's where you guys are. Okay, class work, and you'll see in the class work that I put in the properties of compounds lab. Right? If you click on that, it will take you to a few things. I'll be adding a few things to this as we go, the recording I'm making right now. All right, there's a PDF document in there that is the lab sheet. I'll be working off of that, but it has the questions and stuff on it. Okay, and then there's your Google Doc with your name on it. That is what you need to have open right now because that's the stuff you're going to be filling in today. All right, so when you open it up, all right, you're going to see everything is set up for you. Okay, the skeleton of the lab is already built. All you have to do is fill in the problem, restate it in your own words in the form of a question like we talked about the other day. Okay, identifying and explaining our manipulated, responding, and controlled variables, and I'll go through all of that with you. Okay, generating a hypothesis. I'm also going to go through that because this is the first time you're doing a lab, so I'm going to explain all of this. Like, if you're paying attention, you should basically like get the answers. It's almost that easy, okay, this first time. Then you've got your list of materials. In that list of materials are the possible identities of the unknown compounds for tomorrow. All right, so ammonium nitrate, paraffin, which is candle wax, okay, hydrogen chloride or hydrochloric acid, okay, cobalt-2 chloride, distilled water, pH strips. That's not an unknown, by the way, okay. Those are just some of the things you need. Copper-2 sulfate, sodium chloride, sucrose, nickel-2 chloride, conductivity apparatus, not an unknown compound, I'll show you that. Okay, ethanol, sodium hydroxide, water, okay, scupula, which I didn't bring over, but it's a lab scoop. Looks like a spoon, but with a long handle. Okay, and a thermometer, or thermometer, whichever way you like to say it. Okay, so that'll be the materials that we need, but all the unknowns are in there, right? So you can figure out which one's which. So the procedure, that's what you're going to be also working on today, writing that up, step 1, step 2, step 3. We talked about the 4 tests that you're going to run last week, okay? And I'll quickly go over those again. Then, this part, you won't be able to fill in until tomorrow, okay? This is your data chart. So you'll probably want to do one of two things for this. Either print this at home tonight, but make it big enough that you can write stuff in it, or make sure you have it on your phone and you can enter it in your phone in the lab tomorrow. When we're in the lab, actually doing the lab, you can just type in the observations on your phone from there, whichever way is going to work for you. Okay, and then your analysis, which again we're not doing today because we don't have any data to analyze yet. Okay, in the analysis, all you're doing is identifying is compound A ionic or molecular, and then what do you think it was? If you thought compound A was distilled water, you would write distilled water here. Everybody follow?
Yes.
Okay. Then after that, you'll have your conclusion. We talked about that. Obviously, we're not doing that today either. Okay. Copy and paste your hypothesis and explain why you can accept or reject it. And then your evaluation, identify 2 sources of error and ways to fix them. The class discussion questions you do not have to do. That's something that we go through together after I have handed back your lab reports. So, okay, you don't have to do those. Right? This little scoring thing is down here just so you know what each part is out of, but I don't actually use it. Okay, attached to this is a scoring rubric, which is actually on the PDF document here. Okay, so if you wanted to see the scoring rubrics, they're right there. Okay. Most people never look at them, so I stopped putting them in the Google Doc because it just took up space. Alrighty, so we're going to go through basically some of the pre-lab stuff starting now. Okay. All right, so the first thing we have to put in our lab report is the problem restated in our own words in the form of a question. Right? So the problem I have written here, okay, is given several unknown samples, how can we classify them as ionic, molecular, acids, bases in order to find their identity? Basically, guys, we're trying to figure out how can we identify unknown compounds, okay, in using physical properties. You need to find a way to put that in your own words, okay? Something about. All right. So our next step now is we need to identify our variables, and we need to explain them. Okay? So our manipulated variable is the thing that we're changing each time we do this experiment. So the experiment we already know is going to run like this. There's going to be 12 unknown compounds. We're going to run the same tests on each one of them. All right? So essentially the procedure is going to be the same every single time, just each time we're going to test a different material. So what am I manipulating?
The sample.
The sample, exactly. Okay? My manipulated variable is the sample, the unknown compound. Right? Now, why is that the manipulated variable? The unknown compounds, and if you're listening carefully, you're going to get a big juicy hint here. Okay? The unknown compounds all have different what? Right. What specifically what kind? Physical, right? Physical properties. Okay? And that's what's being tested. Okay? The experimenter is looking for the different physical properties possessed by each unknown compound. Okay? So you know the manipulated variables, the unknown compounds. Find a way to explain what I just said, kind of in your own words there. Okay? That each one has different physical properties, and those are what's being tested. Those will tell us the identity. Without obviously out using us or we or anything like that. Okay, and obviously I'm not going to give you time to type all this in. Just kind of make little notes to yourself here and you can fill in the rest later. All right? Now, our respondent variable, what's going to be different? Each time I test a new material, what's going to change? Yeah, well, there's not going to be any reaction, but it's properties, right? We're going to get different, I mean, our observations here are the physical properties. Okay? So our responding variable is the physical properties of each unknown.
Sorry for the interruption again, but...
Okay, we need to have 3 controlled variables identified and explained in this lab report. Remember that controlled variables are things we have to keep the same for each test, or for each unknown compound, I should say. Okay, we need to keep them the same because they could affect our observations. So, we need 3 of them. We need to explain how and why they're being controlled. Right? So I'm going to give you one with a full explanation, and you're going to have to come up with 2 more, which I'll help you with. Okay? So the first one, the first controlled variable is the tests being run. We are running the same, we don't want to say we, okay? Remember that, we don't want to say we. Okay? The same tests are being run on every unknown compound. So the same set of physical properties can be discovered. The same set of tests is being run on each unknown compound so that the same set of physical properties can be discovered. That's only the first part. Okay? That's the why.
Would that be? We're working on control for that, right?
Yes. Sorry, that's not the why, that's the how. Okay, the other part of this controlled variable, okay, has to explain why we want to do that. Okay? Why do we want to run the same tests? Well, we want to run the same tests so that, okay, each set of data can be fairly compared. Right? It wouldn't do me much good, for example, for me to run an observable properties test, a conductivity test on one, and then a pH test and a solubility test on another, and not have a complete data set for comparison. If I don't get all of those physical properties, I'll never identify them. Right? So in order to make sure the experiment is controlled, I need to have the same data set for each compound. Okay, for your other 2 controlled variables, I want you to think about the tests that we're running, because we've already said the test being run is a controlled variable. That's a procedural. controlled variable. It means we're running the same procedure each time. There are conditional controlled variables as well that have to do with the environment within which the experiment is being run. So what's one environmental factor that could affect, let's say, solubility?
Temperature?
Temperature. That's got to be a controlled variable, right? I don't want to be using like warm water for one and ice cold water for another, or be testing one in a room that's 4 degrees Celsius and another in a room that's 30. Okay, that's not a fair comparison of the solubility. All right, you guys need to come up with one more controlled variable, and it can be conditional, okay, something else about the room maybe, or it could be procedural, something else about what we're going to do, okay? And I would say probably procedural would be easier at this point, all right? And I want you to think about, we're going to have these sample plates, okay? When you're putting unknown sample in these sample plates, what do you want to make sure of, let's say, between samples as much as possible?
Could all grade 10s
How much?
with the last initial and
We're not going to measure it.
please come down to get your picture taken. That's grade 10, M through Q.
Okay, so just before you go here, guys, okay, we're not going to measure it. We're not going to put it on a scale, but should we be careful about putting about the same amount in? You explain why. Okay, all right. If you got to go get your picture taken, go. All right, let's look at the hypothesis now here, guys. So for our hypothesis, what 3 words need to go in it?
If and then.
If and then. All right. The if part of the hypothesis deals with the premise that we are working off of. The premise we are working off of in this lab is that all compounds have unique physical properties. If that's not true, we can't do this
Could all
lab.
grade 10s with last initial R through Z. That's R through Z. Please come and get your picture taken.
Okay, so the if part needs to work on that. Let's just keep going here. All right, so for the if part, as we said, the if part is the premise that we are working off of. The premise we're working off of is that all compounds have unique physical properties. That's what our if part needs to talk about. Okay? If all compounds have unique physical properties. I just gave it to you there. Okay, that's the premise. Okay, that's the if part. If that's true, and an experiment like the one we're going to do is run, then we can predict our results and say what we're going to be able to do. That's how the hypothesis works. So the if part in this experiment is quite short. Okay? If all compounds have unique physical properties, that's it. That's the if. Okay? That's what we think is true. So since I've said that 3 times, hopefully you've written it down one of the 3 times. Okay, the and part of our experiment. So if physical property. Right? The and part is just going to describe the experiment briefly. Okay, so maybe you just say in the and part, and tests are run to discover basic physical properties like, and maybe you list a few. You don't have to list them all. Color, solubility, conductivity, and pH. Okay, you don't have to list out everything. You certainly don't need to say in step 1 do this, and step 2 do this. Okay, it's just a brief description. Okay, that's all the and part is. Brief description of the experiment. All right, the last part of the hypothesis is the then part. And in the then part, we are going to predict our results or say what we should be able to accomplish in this experiment. For us, we're kind of going to say both. Okay? So what do we expect we should get here? right? If I run these tests and everything has unique physical properties, what should I see in terms of my observations? Each compound should? Well, eventually, yes. I mean, they're not just going to magically say after one test, this is, you know, but we'll have to figure it out.
Show different properties?
Yes, absolutely. Okay?
We are now ready to start with the grade 11. So could grade 11
So the then part should say, then each sample should yield unique observations, or different observations, or different properties, or unique properties. Probably don't want to say unique properties because we use that in the if part. Okay? But something about how each compound is going to yield a different set of data, or something along those lines. And what are we going to do with that set of data? Identify the samples. So each sample is going to yield a different set of observations which could lead to its identity, or could be used to identify it, or however you want to word it. Okay? But that's saying, here's my predicted results and what I'm going to do with them, without saying I'm going to do something with them, because we don't want to use I or we or us. Okay? Each will yield unique or different observations which can then be used to discern identity or something. Okay? You decide how you're going to word it. That's the gist of it. Right? And this is, maybe it doesn't seem that way, but this is probably one of the shorter hypotheses you'll have in this course. Okay.
And we're going to hand this in on Google Classroom.
Yes, that is the only end. It will be the file you are working off of right now. Okay, that Google Classroom file that I built for you.
So can we print the table separately and then just
Yep.
use that in the lab and then transfer it over?
Yep, that's what I said to do this morning. Yep. If you want to print it, or you can use your phone. Okay, whichever is going to be easier for you. Probably, you know, if you're like me, you'll probably forget to print it tonight and be doing it on your phone and tomorrow. All right, so that's what's usually involved in the pre-lab. Okay, so when we do pre-labs for all the rest of the labs, that'll be kind of the end of it, is up to the hypothesis, essentially the pre-lab. But for this one, we also have to design the experiment. Right, so you actually have to write out the procedure. This is the only lab where you have to do that. All right, so I'm going to talk about the tests, kinds of things we need to consider, because we said a procedure needs to be an explicit set of steps that tell someone how to perform the experiment. So what did I say you should do when you first walk into the lab? Yeah, or like we could be general and say acquire safety equipment. Okay, something like that. That should be our first step in the
Do
procedure.
you put like 1, then 2, or do we just like write it into the sentence?
No, 1, 2. Got to be a numbered list. Okay, guys, this must be a numbered list. If you write this as a paragraph, even if the numbers are in the paragraph, okay, and I have to go looking for them, it needs to be a numbered list. 1, 2, 3, all in one. Okay, you will lose big marks. Right? It needs to be a numbered list. So step 1, acquire safety equipment. Okay. Once you've got the safety equipment, what should you acquire next?
Get materials.
You should acquire your materials. Now, for us, those materials will all be on a cart at the front of the room. with the exception of your wash bottles, which will be at the back, but don't worry about that. Okay, I'll show you where they are. I didn't bring one in. Okay, so once you have the materials, you're going to need to get your samples. I wouldn't say that samples is included in materials yet. Okay, so you're going to have this depression plate that looks like this one. Right, it only has 6 depressions in it, so you're going to have to do this in sets of 2. Right, so you do 6 and then do the other 6. Right, but I would say that you should, acquire your samples. And should you tell people how much to put in here? Okay, since we're not measuring this by mass, we want to do our best to make sure we get the same amount, but we're not going to measure it. Could that be a source of error?
Yeah.
Possibly. All right. How much should I fill each one of these?
Tip of the soup.
I wouldn't even say 2, I'd say 1/3. Yeah. You want to have enough room for a fair amount of water for your solubility, conductivity, and pH tests. Okay? If you put even like half full with the compound, you'll never get it to dissolve. I would say somewhere between 1/4 and 1/3, okay, full with sample would be lots.
What would you say that would be like a tray?
The depression plate.
Okay.
Yeah. Now, there will be special circumstances for 1 or 2 of the compounds tomorrow, but you don't need to worry about putting that in your procedure, okay? Those are going to be situational, and I will let you know what they are, okay? There's 1 or 2 samples that you'll just put in, and that'll be that. Okay? All right. Once I've got the samples, what test should I perform?
Finding observable.
The observable properties test. Okay? Now, remember, we need to be specific here. You don't just want to write step whatever you're on. Perform observable properties test. And then say nothing. Right? You need to tell people, what observable properties are you looking for? What should you record during an observable properties test? Okay? So performing the observable properties test involves looking for the following things. Okay? We talked about that the other day. Things like color, texture, state, okay? Smell. And any other observable properties you think are noteworthy. Right? It's perfectly valid to tell somebody, here's the things I would record, but if there's something else that you think is valid to record, that's worth recording. Where should they record those observations?
In the chart.
In the chart. Worth telling them that. If they record it on a Kleenex or a napkin, they might lose it. Okay. What test should I perform next? Can't perform conductivity until I have something else. Solubility test, right? Okay. Now, with the solubility test, okay, again, you don't want to just write perform solubility test. Go like do that? What does that look like? Right? We need to explain that. So when we're telling them what to do for the solubility test, we should probably explain that there are going to be a couple of different devices that will be used in the solubility test. A wash bottle, okay, containing what kind of water? Distilled water. Okay, that's important. Should we tell them how much to add?
Yes.
Yes. Do I want to fill this till the very brim? No, because what do I have to do with it? Stir it. Now, you'll notice that these two devices are somewhat different. Okay? One is a thermometer, and the other is a stirring rod. Please do not use the thermometer as a stirring rod. It has a different job. Okay? And I only say that because I see people, they start stirring with the thermometer and then they snap the thermometer. Okay? We don't want that. Okay? So, what you're going to do with this is you're going to have the thermometer in as you add the water. Because what are we looking for? We're looking for temperature changes. So the thermometer has to be in there the moment the water is added. Okay? So you're going to add the water with the thermometer in place.
And how much water were we supposed to add?
I would say fill it to 3/4 of the way full. I wouldn't go much more than that for risk of spilling. And here's the issue. If it spills, it could go into an adjacent depression and contaminate whatever you have in there, and then you'll be doing them both over again, right? So you want to make sure you don't spill into another sample. Okay, so I've got the thermometer in there, and as I add the water, and then I start to stir with the stirring rod. Okay, so it's important to have all those details in there for the solubility test. Now, what else should I be observing?
The temperature.
Yeah, we already said that, but what else? What should I be watching for? I should be watching for color changes. I should be watching to see if the crystals or the sample itself is shrinking, disappearing, changing in any way. Right? Anything, what you want to do basically is say, these are all the signs of solubility. This is what to look for. How long should you give that? Yeah, because I've had some people that they're like stirring one sample, it's like 10 minutes later. We don't have that kind of time, okay? You should really give it like a minute, right? If it hasn't done something in a minute, it isn't gonna do it, okay? So stir and record observations and temperature, okay, for about 1 minute. Okay, what test do I perform next? Now I perform the conductivity test, because now I have a solution, right? If I just put this in a dry sample, nothing's going to happen, right? So I need to have a solution before I do this test. Now, something else with the solubility test also applies to this test. What should I do to the thermometer, the stirring rod, and this thing between tests? Rinse it with distilled water. Don't put it under the sink. Okay, the sink has minerals in it, and you'll contaminate your sample. Okay, just spray it off with the wash bottle and go to the next sample. Not a bad idea to have that in there after solubility test. Rinse thermometer and, as a separate step, right? Rinse thermometer and stirring rod.
Could all Students in grade 11 with the last name starting G through L, please come down to get your pictures taken. That's grade 11, G through L, please come to get your pictures taken.
What was that thing you called again, sorry?
This is a conductivity tester. Well, actually, it says indicator. Conductivity indicator. All right, conductivity indicator is really, really easy to use. Push the button here on the side, and the little red light that says on will light up. Okay, that's important because the old ones we had didn't have that on light. You couldn't tell whether the battery was dead or the solution was non-conductive. This tells you whether it's working or not. Okay, so I take that, I put it in here. What's it reading? 1. Why? Because this is distilled water. Okay, distilled water has basically no conductivity. Right? Now, what do I do with it now? Rinse it. Okay, imagine I rinse. Okay, so it's rinsed. If I have a solution that is an ionic compound, what should happen?
Conductivity should go up.
Yeah, exactly. All right, so I just put a little table salt in there. Okay, so imagine this was like my solubility test. Like even that small amount of salt, yeah, I'm having a hard time getting it all to dissolve, but if I gave it a minute, probably get it all out. Okay, but with this being filled like 1/4 to 1/3 of the way full, you're probably not going to get that much salt to dissolve, but will you be able to tell if it's soluble?
Yes.
Yeah, because you'll get most of it to dissolve. Okay. All right, so now I've done that. Okay, I've dissolved some salt in there. And now, and I didn't dissolve very much salt, it's saying only a conductivity of 5. Okay, 6. I stir a little more, I might get 7. Okay, but this will be a lot more conductive for you guys because you'll have a lot more salt in there. Okay, 2 more. Everybody follow? All right, so that's all you have to watch for. And when you're telling them what to record, you just have to say record the number. Okay, that's on the face. That one's pretty easy. And then obviously rinse it between trials. Incidentally, please don't put this on your tongue. Okay? The light tells you the battery is working. Okay? These things have been in all kinds of really nasty stuff. And rinsing them with distilled water doesn't make that go away. Okay? All right, what's the last test I run?
pH test.
pH test. Okay, pH test is also a pretty straightforward test. All right, take my Hydrion paper, which will come in a vial like this. You can see it's got the color chart on it that tells you what colors correspond to what pH. All right, take off the cap, okay, inside little orange pH strips. You should be able to do 2 samples with each strip. Just tear it in half. Okay, so I just take that pH strip, dip it in the solution. All right, this is going to be pretty neutral because it's just salt water. Right, and then I just compare it color-wise. Yeah, it's probably about a 6. Yeah, closer to 6. That's it. Okay, so dip it in the solution and quickly compare it to the color chart and record the pH. I thought I had pictures of this, but where do I put all the waste?
Isn't there like a special box underneath the lab?
There's a special bucket, yeah, and I don't have a picture of it, but we call it the Disgust Bucket. Okay, and the reason for that is it's pretty disgusting. Right? It's full of all kinds of vile stuff. Don't put your hands in there. If you drop something in there, leave it. Okay, please don't drop anything in there because eventually I have to fish it out. But I'll use tongs or something. Okay. So when you are all done with that sample tray, so you've run all the tests on all 6 things, then take it over to the Disgust Bucket, which will be under the fume hood, okay, and just pour it in and give it a squirt with your wash bottle, okay, and then you can take it back to your sink and do a bit better job and dry it before you test the next 6 things. And then the same thing, when those are done and you're ready to return your equipment, take it over to the Disgust Bucket in the fume hood, give it a wash off with the wash bottle, wash it in your sink, dry it, and then bring it back to the front where you got it. Yeah, that's all stuff that should go in the procedure. Cleanup is part of the procedure, so tell them what to do when they're cleaning things up. Otherwise, people might put it down the sink, and we don't want that stuff to go into the sewer, okay? Or the plumbing in some cases. All right. That's as much as we can do today. So I'm going to give you, you can sit down with your group and you guys can talk about how you want to word everything, okay, get lots of detail in that procedure, okay, you can, work on your hypothesis and your variable explanations and stuff like that. Okay, you have the remainder of class, about another 15 minutes or so, okay, to work on that so that we're all ready to go. So tomorrow we'll have a quick naming quiz to start class, and then we're going to jet over to the lab and get going on this.
Are you making our groups or do you?
Nope, you guys, I always let people choose their groups unless that proves to be a bad decision, okay? Please don't let that prove to be a bad decision, okay? Pick your groups. Please don't leave anybody out, okay? We should have groups of 4 is kind of the safest group size in the lab, and that take up pretty much all the stations, 4 or 5, let's say 5 at the top. Okay, all right. So you guys can work on that for the remainder of class here. Okay, do a good job on that. If you got questions, don't be afraid to ask.